All right, so good morning, good afternoon, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. We are all about bringing conservation, adventure, and science into classrooms around the world. And so thank you to our classes joining us today as we embark on another year of adventure starting in 2019. Right now, we are joined by 5 classes from across Canada, so I want to give them a chance to do a bit of a shout out. We've got Mr. Bordaluzzi's grade 3 through 5s in Thunder Bay, Ontario. Hi, guys. We've got Mr. Martell's grade 4-5s in Port Elgin, Ontario. Hey. We've got Mr. Lister's grade 4s in Chilliwack, B.Sc. We've got Miss Brothers grade 9s in Ottawa, Ontario. Hi, guys.
Hey, guys.
Hey, we've got Miss Walchuk's grade 6s in Cordes, Ontario. Awesome. And last but not least, just joining us, we've got Miss Wu's grade 7s in Summerland, BC. Hi, everyone. Of course, the reason you guys are all here today is for our speaker. So we are joined live by Dr. Zen Mariani. He is a research scientist for Environment and Climate Change Canada, working in their meteorological research division. So he looks at weather, especially in the high Arctic, and how we can improve our weather forecasting and capabilities up there. He is also one of Canada's top 32 astronaut candidates in their 2016 candidate selection process, and has worked in the high Arctic for many, many years as a scientist. So without further ado, I'm going to turn it over to him. Thanks so much for joining us, Dr. Mariani.
Perfect. Well, thanks very much for having me. And hi, everyone. Hope everyone's having a great day. I'm going to share my screen right now, so just let me know if everyone's able to see it. Hopefully this works.
You're great.
Okay. Perfect. Yeah, so thanks very much for having me. I'm going to talk about some of the research I've done over the past few years, researching the Arctic weather and climate. So first, I'll start with a little bit about myself. So I grew up in Toronto. I completed high school, and then I went to University of Western Ontario, which is in London, Ontario, and I did my bachelor's in there. And I was interested in science from day one, so I got a degree in physics. And then I had to figure out, okay, well, what do I want to do with this degree in science? So I went to University of Toronto, and I did my master's and then my PhD in physics. And what I specialized in was researching the climate and weather in the Arctic. And so today, I'm a research scientist, as Jesse said, in the Meteorological Research Division with Environment and Climate Change Canada. So studying the climate change in the Arctic has been quite a passion and something I've been doing for a while now. And one of the key reasons is that the Arctic is warming faster than anywhere else in the globe. So we need to take measurements in the Arctic to better understand this change in climate. And during my PhD, when I was at University of Toronto, I was taking new measurements of infrared radiation, which is sort of like heat near the North Pole. And one of the reasons why this is becoming so important today is if we look at this figure you see at the bottom there, that red line shows sort of this new Northwest Passage. It's a new shipping route that's opening up because of all the sea ice that's melting. And as you melt the sea ice, it allows you to transport goods, materials from Europe, China, anywhere really, across this new Northwest Passage that's going to be a brand new thing that's just starting to open up right now. So we really have a changing Arctic region that's occurring. So when I was at University of Toronto, we did our research in a place called Ellesmere Island, which is in Nunavut. And so what I've shown here is Nunavut is a huge, huge area, but we were located right at the top, sort of at the tip of Canada on Ellesmere Island. And to give you an idea, so where these two red lines meet, that's where we were located. And this is a completely remote location. So there's no one that lives there. There's no town. There's no city. There's no police or schools. The nearest Tim Hortons, for instance, is hundreds of miles away on a different island. So you're really up there all on your own. You're completely independent in a remote area. And so I did research at a lab called Pearl, which you see at the bottom right there. That's that big red building with a satellite dish. And PEARL stands for the Polar Environment Atmospheric Research Laboratory, and it's on top of a cliff. Now, to get up there, so this shows a map of northern Canada. First, we'd fly to Yellowknife, which is not even on this map. It's pretty far away. You'd board this little plane that you see in the top left. The plane it's a rough ride. There's no bathroom. You have to cram in with your knees are basically in your face. All your equipment and your gear is on there. And then you hop from island to island. So you'll hop, refuel, then take off again, land, refuel, take off again. You do this several times until you finally reach Eureka, which is I've circled in red right at the top there. And Eureka is about 1,000 kilometers from the North Pole. So you're really close to the North Pole when you're up there. And when you get up there, this is what you see. So that's me off in the distance, looking off in the cliff. And what should be there in the summer to the right is that's actually the sea. But of course, in the wintertime, it's completely frozen. So it's solid, thick ice. You could land an airplane on it if you wanted to. Now, to get around when you're up there, this is a photo of one of the trucks we have. And you can see something a little different about this truck is the wheels typical tires don't work as well when you're way up there. So they've equipped this truck with these special treads so we can go from place to place from the lab back to our sort of home base so we can sleep at night and get some food and warm up when we were working up there. It was really cool, no pun intended, experience to be up there. So at this Pearl Ridge lab, there is a whole suite of instruments. I was only responsible for one, but there's a big team of researchers from all across the world that install these different instruments, some of which I've listed on the right here. And then these instruments take measurements, and then we then go back to our normal houses here in Toronto, let's say, and we analyze these measurements to tell us more about the changing climate, the temperature, the radiation, the greenhouse gases. There's a number of different research projects happening all at the same time. And this is all part of the CANDAC, which is the Canadian Network for the Detection of Atmospheric Change. So this is a big network of Canadian universities, all the way from Ontario, Halifax, and there's a long list of instruments that I've listed on the left there. Everything from weather balloons that you see in the bottom to instruments called LIDARs, and that's the green laser that you see shooting out of the building, to spectrometers, to telescopes. It's a whole bunch of instruments that we have up there to do different types of climate and meteorological research. Now, one of the cool things about working up there, or even living up there, is you have something called polar day and polar night. And what this means is you're so far north that in the summertime, the sun never sets. So this is a photo of what it looks like over 24 hours. The sun never sets. It just kind of goes up and down. But then the flip of that is in the wintertime, you have 24 hours of polar night. So no matter what time of day it is, you never see the sun. And that can be quite an interesting or different experience because it's just pitch black all the time. And it can be confusing. You don't know when dinner is. You don't know when breakfast is. Are you tired? Are you awake? It can really throw you off. So there's 4 months of polar day in Eureka. And you can get temperatures of around 10, 15 degrees Celsius. But then in the wintertime, you have 4 months of polar night. And then you get temperatures around minus 45. So you see in the middle there, that's a photo of me on the left. And you can see my eyelashes are frozen. So as soon as you step outside, if your eyes water up, it just frosts up instantly. So your whole face gets covered in frost very quickly. And the other cool thing about working up there is it's a desert. So it receives less than 50 centimeters of precipitation, which means it almost never rains. And there's no trees. You're north of the tree line. And the other thing is it's very expensive to do work up there. So just a jug of orange juice costs $20. And that's because you have to ship everything up there. So it's very difficult to do work up there. It's expensive, and it's dangerous too. You have to be very careful that you stay warm. Now, one of the things that I really love when I was working up there is you see a ton of wildlife. So you're in a remote location. There are no people. So there's no humans anywhere around for miles and miles and miles. And so you get to see things like Arctic wolves in the top left. The bottom right, that's a photo of an Arctic fox. And then here's some more photos. So in the top middle there, those are actually bunny rabbits. They're called Arctic hares. And there's a lot of them, and they're pretty cool to see because they're not afraid of you. They just kind of walk right past you when you're up there. There's some more Arctic wolves on the left. And in the very middle there, that photograph, it might be hard to see, but that's actually, I believe it's an Arctic caribou, which kind of blends in, because you can see from the camouflage. And of course, when you're up there, you see some incredible sights, and the scenery is just amazing when you do get these long sunsets. So these are some more of the photos of us up at this Pearl lab doing our work. That's a photo in the bottom right of me working on one of the instruments. So when we go up there, we have to repair our instruments, maintain them, make sure everything's working okay, take our measurements, and then we go back home to analyze all the data. So one of the instruments I was working with is called an AIRI, and we take measurements. You can see right at the top of the map there, Canada, Eureka, University of Toronto. We were taking our measurements. But there's a lot of these other instruments located all across the globe. Germany has a few, South Korea, Australia, the US. And what that allows us to do is we can compare our measurements to other places around the world. And that lets us, gives us some information of, okay, if we're seeing certain changes, are we seeing more changes in the Arctic? Are we seeing less changes? And if so, why is that? So after I did my PhD, soon after that, I moved and started to work at Environment and Climate Change Canada, where now I'm a research scientist. So what my job basically is I lead research projects that aim to improve the weather forecast and weather observations. So I work on developing new super sites. So one is in a place called Iqaluit, Nunavut. So that's the capital of Nunavut. And another one is in Whitehorse in the Yukon territories. And Whitehorse is the capital of Yukon. And then I install these instruments, we take measurements, I publish some new scientific results, so we show our data to the international community, and we take these new measurements with these brand new instruments that we've installed. And so as part of my job, some of the skills that you need, or that have come in really handy, is your math, science, physics, chemistry skills, at least for me personally. There's other people who do other Arctic research, and then you need, biology or geology, different types of science skills. For me, I find it's been very useful having some computer coding skills, and then, of course, having some electronic skills. So a lot of my work is hands-on. I have to go in with a screwdriver or with wires and fix instruments, and that's actually what I like. I'm not just working at the computer. I'm also out in the field working with my hands. And then, of course, you have to have communication skills. So things like doing presentations, you have to talk about your results with your colleagues and people from all around the globe. And then perhaps the most important skill is teamwork. So you're constantly working with other people. You have to work out in the field. You're living together. You're working together. So it's something that has been extremely important to do research, particularly in the Arctic. So what I'm doing now at Environment and Climate Change Canada is I'm working on what are called integrated observing system technologies. So in this figure, I'll start from the top and work my way down. So we know there's a bunch of weather satellites that orbit the Earth. So we look at taking the different satellite data that gets beamed down to the Earth. But then I also work on taking measurements in aircrafts. So we have special campaigns where aircrafts fly and take measurements of the atmosphere in special areas, and then we look at analyzing the aircraft data. And then we have something called radio sounding, or balloons. So we launch balloons from all across the globe, actually, at different sites every day. And these balloons take measurements of the atmosphere as they go up in the atmosphere. And then we look at measurements taken from ships, taken from the surface, so your sort of standard surface weather stations, and from other instruments such as microwave radiometers, LIDARs. So LIDARs are, again, I showed a photo of, for instance, that green beam, that comes from a LIDAR, and automated weather stations, and in particular, weather radars. So the research group that I'm in spends a lot of time deploying weather radars and looking at weather radars, and that lets us know whether there's a big storm coming in, whether we can predict perhaps a tornado that's occurring, whether it's going to rain today. These are some of the key technologies that we use to improve our weather forecast. And it's what I'm looking at is tying these different observations together and seeing how we can use them all simultaneously, all together at the same time. And one of the applications for this, so what can we do with this? Well, we can improve our weather forecast. And so on the left there is an image showing what we do with a weather forecast is we use a computer to sort of predict what the weather forecast is going to be in the next few hours or few days. And to do this, we divide up sort of the map of the area around Canada into a grid. And so we can have these grid boxes as small or as big as we want. For instance, if each grid box is 10 kilometers big, then you're only kind of capturing big chunks of the city. So for instance, if this is Toronto, that's the size of a grid box in Toronto. And I've shown a little photo of the CN Tower. So, there's the lake. Ontario is just to the south there. But what we've been able to do recently is decrease the size of these grid boxes so we can make smaller grids. And that allows us to have more accurate data. So for instance, if this is 10 kilometers, this is what it looks like at 2.5 kilometers. So now we can see smaller grids. That gives us more information and more detail about what's happening locally in your local area. And that helps us improve forecasts for extreme heat, precipitation, so rain or snow, strong winds, air quality, and so forth. And recently, we're looking at an experimental model that has a resolution of 250 meters. So if you run in the track and field team, a 100-meter dash, so the size of each grid around all across Toronto in this case would be just a little bit longer than that. So 250 meters is very, very high resolution. And with that gives us a lot of detailed information and it helps us improve our weather forecast. But the question is, how can we use the observations? What data can we pull in to this weather forecast, to these weather models that'll help them be more accurate? And we can see that when we increase the resolution, for instance, the top left shows what we forecasted the clouds to look like at low resolution, and the top right shows what they look like at high resolution. So we see a lot more detail. And then we compare that with what does the satellite see, and we see that, the satellite sees pretty much what the high resolution forecast looks like. So this is our way of checking to make sure that, the high forecast is doing a better job, the high resolution forecast, that is. So I work on the Canadian Arctic Weather Science Project. And in this project, you see these two maps on the right here. This is northern Canada. The top map shows where are our primary transportation routes. So these are the sort of the sea transportation routes that are occurring in the Arctic. And the bottom map shows where are the weather hotspots. So where are most of our storm tracks in the Arctic. And that's why we've installed these new sites, one at Iqaluit, that's the star on the right, and one in Whitehorse, which is about the star in the left. And we've equipped these two sites with new instruments to ask this question, how can we install these new instruments to look at to help these high resolution weather forecast models? And it's because weather is a challenge to forecast in the Arctic. We don't have a lot of data in the Arctic, and that's why these observations hopefully prove to be quite useful. It allows us to also ask, how can we provide accurate information to the local communities, to the people living in the Arctic? And what is required? What instruments do we need, and how often do we have to operate them? So this is a photo of the Iqaluit supersite. So this sort of shows what Iqaluit looks like in the springtime. So we can see there's no trees again. We're north of the tree line. There is a city in Iqaluit, though. There's about 12,000 people that live there. And we've equipped it with a whole bunch of instruments, LIDARs, instruments that measure precipitation, rain, snow, weather radars, radiation. And one example of this is what Iqaluit looks like up from above in the spring. And then again, of course, because we're there in the winter, it does get some snow, and our instruments get covered in snow. We have to make sure they're maintained properly and taking measurements the whole time that this is happening. And I'll just leave it with, this is one photo. This is at Iqaluit. This is one of our LIDARs. So you can see it's a green laser. Kind of looks like the Death Star laser shooting out into space. And in the background there is the aurora. So this is a photo by one of our operators up in Iqaluit, Daniel Coulomb. And it's an incredible glimpse of what it looks like when you're up there working in Iqaluit. This is what you see at nighttime sometimes if you're lucky enough. And with these LIDARs and these new observations, we're able to measure very high resolution, detailed information about the atmosphere the temperature, the pressure, how much water there is, and that will help us improve our weather forecasts, particularly in the Arctic, where we see some really severe and nasty weather, some blizzards and some dangerous weather that can affect people that are living up there or that are just flying and flying through or are going through by transport. So that's all I had on the research that I'm working on and some of the different aspects of the Arctic research. So thanks very much for your attention. And now I'll open it up to whether there's any questions.
Outstanding. Thank you so much, Zen. I bet that's the only presentation we will ever have with a Death Star laser reference with the Aurora and reference to the nearest Tim Horton. So thank you for that. That was the most Canadian line of all time. All right, let's head to Mr. Bordaluzzi's class. If you guys want to kick us off with a question, go right ahead.
Number 1.
Yep, you're good.
Does climate change make it more difficult to predict weather?
Yeah, I got it. So will climate change make it more difficult to predict weather?
Yep.
Great question. Actually, that's a huge question right now in research. There's a lot of people from all across the world actually looking into that, and it seems that some people seem to think that because the climate is changing, what we used to expect as the weather, what used to be sort of normal, that's going to change. And because that's changing, we're going to enter some new sort of weather patterns. Or we might see certain weather types, such as severe weather or heavy rains or flash floods. Those things might be happening more often. So it's still an active question. I wouldn't say there's a definite answer yet, but it does seem that, yes, in general, it will make forecasting a little bit more challenging.
Okay. Let's head to Mr. Martel's class for the second question.
What equipment can you have to keep yourself safe while using instruments?
Another great question. So when we're in the Arctic, because it's so cold, we wear these huge parkas. I wish I had one on me, but basically it's the super thick parka coat with a big hood with, you wear a full ski mask, you wear gloves on top of gloves on top of gloves, so you keep your hands warm. Really what you're worried about is frostbite when you're out there working. But then when you're working with the equipment, you have to use your hands. So you have to be very careful that your hands are warm while you're working outside. What we usually try to do is we bring the equipment inside where it's warm, and then we can take off our gloves and get in there with our different tools and do whatever we need to do on the instrument. And usually one of the best ways to be safe is make sure that you're working with at least one other person so that both of you can watch each other and you're being safe the whole time.
Great question. Before we go to our third class, I want to note there's a few groups watching on YouTube Live. So if you guys want to pass on questions on the chat bar on the right, I'll pass them on to Dr. Mariani. So please do that. Don't be shy. Let's head to Mr. Lister's class for a third question. Take your time, no hurry.
Hello, my name is Riley.
Hi.
I just wanted to know if in like 75 years, if climate change becomes such a problem that Earth is no longer habitable, do we have a plan B?
So that's another good question. So in 75 years, we don't think that it's going to be inhabitable. So we'll still be able to live on the Earth in 75 years. It's certainly, there's a lot of concerns related to climate change, and it might be, depending where you live, it might be a lot more difficult in terms of some of the effects of climate change, such as sea level rise or so let's say severe storms, for instance. But it won't be inhabitable in that sense. There's still some research looking at what might happen longer term, though. So what might happen not just 75 years, but 100 years, 200 years later. How serious will that be? But in terms of the entire Earth being inhabitable, that hopefully shouldn't be an issue. It doesn't seem like that would be the case.
we bring on a lot of space researchers, and they always like to point out when people talk about going to Mars and settling there, that no matter what happens to the Earth, I mean, and we want to keep it as good as possible, it will still be more habitable than Mars is.
Yes.
It's like the
Definitely.
ultimate. It's so hard to live elsewhere in the solar system. The Earth is perfect. So
Yeah.
that's
We only have one Earth, and so far no plan to leave it. So that's why.
Let's treat it well. All right, let's go to Miss Brothers' class for a question.
What kind of training did you have to do as an astronaut candidate?
The question was, what kind of training do I have to do as an astronaut candidate?
Yeah.
Yeah. So the astronaut candidate program was separate from Environment Canada, Environment Climate Change Canada, and basically the Canadian Space Agency had an open call. They said any Canadian that wants to apply can apply, so I applied. And what they then did over a course of about a year is they sent a whole bunch of tests out. So you'd have to pass a test, and you go on to the next round, and you pass the next test. So it's everything from math exams, logic exams, physical exams. You're in a gym competing with other athletes. You're running around. You're problem solving. You're swimming in the pool. It was a whole suite of tests, and as soon as you think you're done one, they ask you to do another one. So it was a lot of fun I had, and it was an interesting experience, and it certainly was a very intense testing and training period.
Very cool. All right, let's go to Miss Walchuk's class. You guys have a question?
Nope, it's on.
How long have you been doing research on climate change, and what changes have you seen in that time?
Ooh, good question.
Oh, yeah, that's a good question. So I was doing research in climate change for about, I'd say, 6 years. And then the past 4 years, I've shifted from climate change research to weather research. But I'd say, so in about the whole 10 years, we've seen a lot of scientific data, a wealth of scientific data that looks at trends. So we look at how much the climate has changed over 10, 20, 50, 100 years. And what I've seen is it's very clear that there's a lot of signals that the climate is changing. And where we see the change, for instance, if we want to look at temperature, so where is the Earth heating the most? We see the greatest changes in temperature are occurring in the Arctic. So for the people living in the Arctic, they're sort of at the front line. They're seeing the fastest change, the greatest change happening right now. And in terms of change with my own eyes, you sort of, as you visit up in the Arctic, you do notice certain things that have changed. And when you speak with the people that live up in the Arctic, in the communities up there, and they tell you things that, like, their hunting season has changed. They used to be able to go out on the ice and hunt at a certain date, and now that date is a week later, and because it's just warmer, there's less ice, or the conditions have changed for them. And that can be very dangerous, because if you've always done the same, you're used to a certain weather pattern and hunting patterns, you've been used to it, your father, your grandfather, and then you go out and things are different all of a sudden, you can get stuck out in the ice, and it can lead to a lot of problems. And this is what we're starting to see happen right now, especially to the people living up in the Arctic.
Great question. All right, let's go to Ms. Wu's group. If you guys have one, come on up.
You might have a question and things like that?
No.
We don't have questions right now.
That's okay. We can come back in a bit.
Yeah, okay. Thanks.
Good one. Miss Painter's group, I know you guys came in a little late. If you want to ask a question, you can. Hey. Oh, you're muted for some reason. That's weird. Because I have you demuted, but I can't hear you. Yeah. No. So worst case, okay, try and figure it out. I'll come back to you in a minute. No. Still not. So try typing it in. Type in the question, and I'll get it in a minute. Perfect. All right. We'll go back to Mr. Bortoluzzi's class, and we'll come back in a second. Morgan?
Why do you want to be an astronaut?
Why do I want to be an astronaut? Good question. You know, when I was a kid growing up, I basically, my parents took me to see a movie. I'm not sure if you've ever heard of the movie Apollo 13, but I saw this movie and I thought that looks like the coolest job in the world, working up in space, and you're working with all these cool people, and there's this big project and everyone's working together and you're working with all the coolest instruments and everything's, you know, cutting edge. And ever since a kid, I thought that looks amazing, and why can't I do that? So since I was a little kid, I just started to get really interested in science and space. And ever since I was a kid, so I just started taking more science classes, physics, chemistry. I took a lot of math classes, and I stayed interested. So when there was a chance, when the Canadian Space Agency said, "Hey, do you want, you know, whoever wants to try can try," I came out and said, "Yeah, sure. You know, why not give it a shot?" And when you look at some of the Arctic research that I showed, a lot of the stuff we do up in the Arctic is kind of like, sort of like you're living, you know, on another planet. You've got to put on all this equipment. You've got to work with a team. You're living together. It can be very stressful. You need lots of science. And so there's some applicable skills that probably help me in that whole process.
Outstanding. All right, so we had a question from Miss Painter's class, and I'm sorry we couldn't get the audio working, but the question is, how long can you leave the instruments in the cold before you have to bring them back in or take them down?
Yeah, great question. So really it depends on the instrument. But what we typically do is when we install an instrument, we make sure that whoever's built the instrument, it's qualified to live in the Arctic, to survive. And really what we usually do, especially in my current position, so at Environment Climate Change Canada, we actually have a freezer that's about the size, you know, maybe half the size of one of those classrooms that I can see in the bottom there. So imagine if half your classroom is this giant freezer, and we can freeze that to -40 or -50 degrees Celsius, the whole room. And then we stick in our instruments that we want to see. Oh, let's see if this survives in the Arctic. And we run it there first. And that lets us test it. Okay, will this work? And once we see that it's worked, then we deploy it and install it in the Arctic. And so usually, one example is one of those LiDARs, those lasers I showed a photo of earlier. That LiDAR, we basically placed it on the ground, on a roof, out in the Arctic, completely exposed. And we haven't touched it in 2.5 years. So some of these instruments do really well. They have heaters inside, and they keep their internal sort of important components really nice and warm. And the outside's built like a tank, so it can just survive, you know, ice and snow and blizzards. And in that case, you know, that's what we want. We want instruments where they can survive a long period of time, and that way we don't have to keep spending money to fix them.
Excellent. Which is very similar to a space station too. I mean, the parallels aren't too removed from what you have to do out there. All right, Mr. Martel's group, you got a second question.
What are some safety cautions, concerns about working so far north?
Yeah, that's a good question, actually. It's something that you have to be very careful planning when you go up there. Because when you go up to the Arctic, especially those first few slides I showed in that remote place called Eureka, there's no hospital, there's no doctor, there's no police, there's no, you know, there's no extra food store, there's no grocery store, there's no Canadian Tire. If you forgot a drill bit or something, you can't just run across the street and, you know, buy it. So you have to spend a lot of time planning, not just what do you need, but what if this happens? What if A, B, C, D? What if these things happen? What will I need? And then you have to bring that with you. So typically when we travel, we bring a ton of equipment. The sort of the philosophy is it's better to have it and not need it than to not have it and need it. So really what it comes down to is every time we go up, everyone sits in the room and we brainstorm. What are you going to need? What are you going to need? What if A happens? What if B happens? But then you have to plan for things like medical emergencies. Do you have any medication that you might need to bring? Should you bring twice as much? What if you get stranded up there? What if the plane can't land and there's a blizzard and you're stuck up there for another week? So you think these things through first, and that way when you're up there, there's hopefully no surprises. And luckily, in my experience, when you're working up there, you rely on your team, and you're working with incredible people. Your colleagues and your teammates are just wonderful people, so that if something does go wrong, they're there to help you, and you can problem solve. And you don't panic. You stay calm and you say, okay, well, how can we fix this? And luckily, every time nothing seriously bad has happened to me or anyone on any team that I've been a part of. And it's all been a really, really wonderful experience.
Excellent. Preparation is something that we hear about in a lot of our hangouts. Is just you run a much lower risk of having difficulties if you plan for absolutely every contingency ahead of time. So I'm glad that message. Miss Painter's class, I just want to note for you guys, just in case the mic doesn't work, if you want to type in more questions, please do. A quick follow-up to Dr. Mariani as well. So as far as safety goes, you showed Arctic wolves, which could potentially pose a threat to people. Are there polar bears up there too? Is there any animal danger potential?
Yeah. In Iqaluit, Nunavut, it's not as much because you're living in a city. So there's about 12,000 people. Polar bears do come by. However, the whole city sort of acts to prevent that from happening. In Eureka, though, because it's so remote, that is definitely more of a concern. So what we would do is, firstly, you never travel alone. You always travel in a group. Secondly, you always have a radio or a walkie-talkie, so that if you do spot something or if you find yourself in a dangerous situation, you can radio the base for help. And thirdly, in terms of the wolves, it's actually kind of cute. The Arctic wolves are curious because for them, they look at you, they smell you, and they say, well, what is this thing? What is this thing walking around? And so they're not aggressive. They're more they're just curious. They want to figure out what you are, and they keep their distance. But you have to make sure, of course, you keep your distance. You don't want to get close. These aren't dogs the way we would have at home. These are wild animals that can be very hungry. In terms of polar bears, so I myself have never actually seen a polar bear in the wild, but it frequently happens where they just wander by the base at Eureka. And when that happens, an alert goes out. Everyone goes in the base. You stay indoors, and basically they try to shoo the bear away peacefully, because that can be a very dangerous situation.
Okay. All right. Let's head to Mr. Lister's class.
Okay, Sheldon, introduce yourself first.
Hello, my name is Sheldon.
Hi, is Sheldon?
Yeah.
Hi.
Is there a better alternative to burning gas for electricity?
Is there a better alternative to using gas for electricity? Good question. Do you mean just in the Arctic, or do you mean everywhere?
I don't. Everywhere.
Can I help you?
Everywhere. Okay.
I think we've been talking about greenhouse gases and the effects of burning fossil fuels, and so the question I think is related to: are there better alternatives, and why don't we use those alternatives?
Right. Great question. That's the big push that's happening right now, is trying to get people to switch or use less fossil fuels and use more of these green energy technologies. So the best example I can give is solar panels and wind farms, for instance. These are green sources of energy. They're completely renewable. And what's really exciting is 15 years ago, when I was researching this, solar panels were much more expensive. And people said, well, why would I put a solar panel on my house? It's so expensive. I'm just going to keep, doing whatever. And today, solar panels have become so cheap that it actually makes sense. If you put a solar panel up in your house, well, then you can power all your entire house. You have electricity. And then if you have a green car, an electric vehicle, like a Tesla or a Chevy Volt, then you can plug in your car and you're never burning fossil fuels. And so that's the big push for what's happening right now. It's slowly starting to happen, and I really hope that this keeps going so that in the future we don't have to burn anywhere near as many fossil fuels, because that's the big danger that's happening right now. That's really significantly contributing to a lot of the climate change that we're seeing.
It's worth noting too, just because we have so many Ontarian classrooms here today, that among places in the entire world, Ontario actually has one of the lowest amounts of electricity generated by fossil fuels. It's nuclear, it's hydro, it's wind. Certainly if you're in farm country in Ontario, you see a lot of wind farms, and solar panels, as Zen said, are increasingly popping up everywhere, which is a great sign for the future. Let's head to Miss Brothers' class. You guys have a question.
Hello?
Hi.
Hey.
Hi. What's the longest time you spent in the Arctic?
The longest time I was up in Eureka for, I believe it was 5 weeks. So plane drops you off, you've got your backpack and your equipment. You don't have a cell phone. The internet there is so bad you might be able to send an email or two, and you're up there alone with your team for 5 weeks until the plane comes back. And so, it's a lot of fun, but by the end of 5 weeks, when you see the plane land to take you home, you feel really happy to be going home, because it can get kind of lonely. It's tough work out there.
Awesome. I'm glad that got brought up. All right, let's go to Miss Waltrip's class. Got a few more questions to go. You guys have a one?
Because I gave Dawn.
Yep, you're good.
Tiny bit. Back up. There we go.
Our question was about your astronaut training. What will happen next for you?
What will happen next for me?
Yeah.
Yeah. So the Canadian Space Agency astronaut recruitment campaign ended last July 1st. So on Canada Day, they announced Canada's next 2 astronauts. So one wasn't me. And so what happened with me is I just have continued to work at Environment and Climate Change Canada. So the astronaut campaign was sort of separate from my job. And once that ended, I'm back and I continue to do Arctic research so that I showed in the presentation earlier. So it's sort of, for me, it's just sort of back to business as usual, back to my old life, living at home and doing the research that I was talking about.
Right. So, Tracy, yeah, I'm going to come to your class in just 1 second to take last 2 questions from you guys. So that's great. I'm glad you have them. I wanted to pass along Miss Painter's class other question, which is, what's your favorite part of the job? What do you like the most and what do you like the least?
Oh, geez, that's a good question. Okay, let me think. My favorite part of the job is probably being able to travel. I love working with my hands and working in the field. And don't get me wrong, it's very comfortable to sit at your computer desk and you're doing everything in the office, but to be able to go out and explore and see this completely new place, whether it's the Arctic or whether I'm going somewhere for a meeting and meeting some of my international researchers and we're discussing the research that we're doing, it's definitely a huge bonus. So I remember when I was first told 10 years ago, oh, you're going to have to go to the Arctic to do research. I said, I don't want to go to the Arctic. It's cold up there. Why would I want to go up there? And then I thought about it and I was talking to my parents and they said, almost no one ever gets to go up there. So think about what a cool experience it would be. You're going to see this place, this part of Canada and this terrain and this environment that almost no one ever gets to experience. And when you think about it that way, it's like, oh yeah, this is really cool. This is really unique. And I'm really lucky to be able to see this completely different thing that no one really gets to see. The part of the job that I maybe don't like as much, oh geez, I guess sometimes it can be really tough because it takes a long time to be certain that the results you're getting are correct. So you have to spend a lot of time poring over the data and being very meticulous. And it can what you think might take, oh, just 1 month, I'll be done. It can actually take you several years. And so I guess it's not that I don't like that. I guess it can just sometimes be frustrating that you have to really slow down, take your time, and be patient. And at the very end of the day, you might think what you wanted to do would take an hour. It actually takes a whole week. But at the end of the day, it's worth it. And that way you're able to produce some really good science.
Outstanding. I'm so glad I got that question too. All right, so Ms. Wu's class, if you guys want to end us off with 2 questions, come on up.
Okay. Does climate change affect the behavior of animals?
Does climate change affect the behavior of animals? Now, that's a fantastic question. So unfortunately, I'm not the best person to ask. So most of my research, I look at the impact of climate change, and I look at how the climate's changing and the weather. In terms of wildlife, I'm not too certain, but I do know that it's a very big area of research for other people that I work with, some of my colleagues at Environment and Climate Change Canada. So there's a huge group of people who are researching wildlife and the impacts of wildlife, the impact that climate change has on wildlife. And so I believe the short answer to your question is that yes, climate change is definitely impacting wildlife, and we can look at different species from the deer to caribou to birds and how this is having an impact. But unfortunately, I don't know the details to that. But if you're interested, we can maybe chat later, and I can provide you with more information from someone else at Environment Climate Change Canada who has those details.
That would be marvelous. So we can certainly take questions, like if any class or student wants to ask questions to us at Exploring by the Seat of Your Pants, we can pass them on to Zen. We can work with Climate Change Canada. So if you want those sort of answers, we can get them for you. And yes, the short answer is yes, we've done work with a bird observatory in Idaho. We did a bunch of hangouts last summer that were really, really good and detailed exactly that, how climate change has been affecting their migration across North America. So right, let's do one last question from Ms. Wu's class, and we'll wrap it up after that.
Hi.
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 Is there a time limit for how long you can stay in the Arctic, like as a day?
No, there's no time limit. So really what it is about is whether you're dressed appropriately. So there are local communities that have lived there, people who've lived there their entire lives. And and there's permanent communities too, people who've, their parents, parents, and they've lived there forever, basically. In terms of being outside and exposed, if you're out in the winter and it's -50 and you're starting to frost up, that's a different story. So I've been outside, a couple hours at a time is not a problem, as long as you really dress warm. The key is skin exposure. So if you're exposing any skin, even this part's actually the worst, right under your eyes. That's why we usually wear ski goggles or ski masks. I've been outside a couple hours, no problem, but a little bit longer than that, you might get a little cold and you might want to come inside or eat something, because it starts to get at you.
All right, Zen, before we wrap it up and have the classes give you a big thank you, is there any last message you want to share with the classes? Anywhere else they can look things up? Any last words?
Just a big thank you. Thanks very much for having me. I hope this was interesting. Definitely, if you have any other questions, maybe something you think of later, I'm sure you can contact either Jesse or myself, and we can email each other, go back and forth. We can even have another Skype session if your class is interested. I'm happy to talk more, more detail about what I do. And so otherwise, just thanks very much. It's great to see that there's some interest, especially because, I find a huge chunk of Canada is the Arctic. And we don't, as Canadians, we live close to the southern border. A lot of us don't really think about the Arctic too much. So it's great to see that there's this interest, because it has what's happening in the Arctic has a huge impact on the rest of the country, not just for the people who live up there, but from a number of different aspects. And so it's important, because what affects the Arctic is going to affect everyone else. So thanks very much, and yeah, definitely let's get in touch if you have any other questions.
Marvelous. Well, boys and girls, I'm going to demute the mic of every single class. So if you guys could get ready to join me, and a huge thank you for Dr. Mariani. Everyone is demuted. Go right ahead, guys. Thank you so much. Awesome, guys.
Thank you.
We look forward to having you guys.